Welcome back to Akbar Academy Podcast, the show where physics isn't just theory, it's the language of the universe. I'm Kaleem Akbar, teacher, author, and your friendly guide into some very powerful ideas. Today, we're diving into energy. And to help me unpack it, I'm joined by the two people who helped define what energy really means, Sir Isaac Newton and Professor Albert Einstein.
Energy may be unseen, Mr. Akbar, but its effects are ever present. I found that the motion of objects and how it changes is governed by consistent laws.
Indeed, and centuries later I found that mass and energy are not separate things at all. They're two sides of the same coin.
Let's start with something that'll surprise our listeners. One lightning bolt carries enough energy to power a typical house in the US for over a month.
Ah yes, energy in extreme concentration. And whether it's lightning or a star exploding, the principles remain unchanged. Energy transforms. It doesn't vanish.
Now imagine a roller coaster right at the top of its track. But it's loaded with gravitational potential energy.
A perfect example. Based on my law of universal gravitation, we know that the car's energy depends on its mass, its height, and the strength of gravity. At 50 meters high and 1,000 kilograms in mass, it holds approximately 490,000 joules.
As it drops, that potential energy transforms into kinetic energy, speed. Plus, some energy becomes heat and sound, especially from the screaming riders.
And that's the beauty of the law of conservation of energy. Energy does not vanish. It simply changes form. That applies whether you're falling on Earth or fusing hydrogen in the core of a star.
Now let's talk bigger scale. Hydroelectric dams. They're like nature's batteries.
They store gravitational potential energy in elevated water, exactly as I described in classical mechanics. When released, the water's motion becomes electrical energy.
But energy transformations are never perfect. Some energy is always lost, typically as heat. My work in thermodynamics and relativity shows that there's always a cost to conversion.
Exactly. Remember those old incandescent bulbs? Most of the energy they used became heat, not light.
Which is why modern LEDs, 90% more efficient, are such a leap forward. But even then, you always spill a bit, so to speak.
Now, here's the exciting bit. Fusion, the same reaction that powers our sun.
And here's where my most famous equation comes in. Energy equals mass multiplied by the speed of light squared. That tiny bit of mass lost in fusion, it becomes a massive amount of energy. At ITER, scientists are heating plasma to 150 million degrees Celsius, aiming to replicate this on Earth.
Remarkable. In my time, such energy was unthinkable. Yet your theory shows that mass itself is a reservoir of energy.
Until fusion is ready, we're making progress with renewables. Solar panels are twice as efficient as a decade ago. Wind turbines, some can power a home with a single rotation.
Impressive. But let us not forget, no matter how advanced the machine, it must still obey the conservation of energy.
And that's the law students must know. Energy cannot be created or destroyed, only transformed. Whether it's food turning into motion in your body or petrol into movement in a car, the principle is the same.
The human body, in fact, converts food into mechanical energy with about 25% efficiency. Better than many engines.
And if you've ever seen a Sankey diagram, it's a brilliant way to visualize these flows. In a power station, only about 35% of energy from fuel becomes electricity. The rest, lost as heat.
So the challenge ahead lies not just in producing more energy, but in using it more wisely.
Smarter grids, better batteries, cleaner sources, all part of the solution. But they must be grounded in scientific understanding.
And that's why energy is the perfect topic. It connects every part of physics, from a falling apple to a fusion reactor, from your morning jog to the orbit of a galaxy. It all runs on energy. And here at Akbar Academy, we're committed to helping you understand it, because we are always a class above the rest.